Okay, we're going to start our Cornell notes, explore number one on gravity here. Let's just kind of take a moment to focus where we're at. Make sure you're in your physics text. Okay, we've already done unit one, of course, and here we are in unit two, and we're on 2.4, right? Drilling down into these specific fundamental forces. And let's click on gravity. And if you take a look at the Explore, you'll notice that there are 7 Explore pages. And so we'll go ahead and take care of our first one here. Go ahead and draw your note-taking template. Go ahead and write the date. And go ahead and write down the essential question. It's the green one here. How is the magnitude, that's like strength, how is the magnitude of the gravitational force between two objects related to their mass or to their masses and the distance between them? Question mark. Okay. How is the strength, the magnitude of the gravitational force between two objects, say the sun and the earth, or the earth and the moon? How is that gravitational force related to their masses and the distances between them? You should know something about this by now, because when we were doing our 2.1, looking at the fundamental forces, we briefly touched a little bit on this and talked about the equation, if you recall, uh, force of gravity, right? And how that was equal to the gravitational constant, dot, dot, dot. I'm not going to say anything more, but I want you to now tell me what you know, okay? What I know or think. Okay, so go ahead and hit pause and write down something. A couple bullet points, maybe a sentence, maybe 2 sentences. Okay, I hope that you took care of that and you got something down there. Let's go and start with Roman numeral 1. We're going to take this title, gravitational force, and use that as Roman numeral 1. Okay. There is a force that pulls the moon towards the center of planet Earth. This force acts on the moon during every part of its orbit. The force is proportional to the masses of both the moon and the Earth. This force is gravity. Okay. The gravitational force, second paragraph, is an interaction between any two objects in the universe that have mass. Maybe that's where we should start. Okay, so we'll say letter A. Um, Gravitational force. It is an interaction between any two objects in the universe
All right. Sit. Yeah.
that have mass. Okay. Examples, i.e., we have the Earth, and from the center of Earth, it exerts a gravitational pull towards the moon. And maybe we've got the moon over here. And the moon also is demonstrating an attractive. Both of these objects are being drawn towards each other, force of gravity, right? Okay. Um, the magnitude of the force of gravity is directly proportional to the masses of the objects. Let's go ahead and write that down, okay? You know that.
Good for you.
Good. I they don't compost at Jax's house.
Oh.
And this is just like carrot peelings and the carrot top. I think it's interesting too.
Oh,
I
yeah.
don't know if this it's just set aside. I can put it in the
Is
compost
directly.
if you want it like for
Directly.
Yeah, let's set it over.
That's an
there.
important concept there. Proportional
They would love that.
to
Carrying
the masses
packing it up.
of the objects.
Yeah, I've been doing that too with them.
Okay. And you should also be thinking to yourself about what it is indirectly or inversely related to. Okay. Okay, so let's just put this down. So, because Earth and Moon have large masses, comma, the force of gravity between them is large, right? Okay. You have a nice video here measuring gravitational force. Please watch that. Okay, it's a 23-second video. Make sure you watch that. Your text includes these videos. It is important. Okay. Now, this next paragraph, the force of gravity is smaller when the two objects are far apart. So now we're not even talking about mass, we're talking about the distances. So let's go ahead and write that down. This will be letter C. The force of gravity is smaller when two objects are far apart. Okay. And let's see here. If we look at this last paragraph here, gravitational force is inversely proportional. Okay, so we'll go ahead and just put that in parentheses. I'm going to put this in red here. The force of gravity is inversely proportional to the square of the distance between two objects. Okay. So force of gravity is inversely proportional to the square of the distance. And we said that look, I'm not even going to change my color of my ink here, just so, and we said that the magnitude of the force of gravity is directly is directly proportional. Okay. The reason why I'm doing these color codings now, you've already written this out, but let's go ahead and write something now that you are familiar with, right? Remember. Do you remember this? Force of gravity is equal to the gravitational constant times the mass of object 1 times the mass of object 2. Those are directly proportional, right? They're in the numerator, and they are inversely related to the distance squared. So there's that color coding there, right? Okay, I'm sure you remember that. And of course, you remember what the gravitational constant is, right? If not, go ahead and take a look back in your notes because you have already written that information down there. Okay, well, that takes care of this. I guess we should just kind of say that as distance gets bigger, increases, the force of gravity decreases. That's what we mean by inversely related. Okay, and if we take a look up here in the numerator, as mass increases, then what happens to your f of g? Then f of g also increases, and vice versa, and vice versa. That is to say, as mass decreases, your force of gravity too decreases. Okay, so that's why we say that this is directly proportional, the top ones, and the stuff in the denominator is indirectly. Okay, so we would say directly related, or AKA proportional, and everything on the bottom is indirectly related, aka proportional. Proportional. We could also use the word inversely related. Okay. All right. So a lot of different ways to express this stuff, and guess what? We're done. That was great. I like it when they're small and short like that, and I know that you do too. So let's go ahead and just write a summary paragraph, okay? And we'll talk to you soon. All right, take care. Bye-bye.